Okay, let's take a look at number 6, multi-part problem here. We're first going to calculate this limit. So the limit of this sequence, right? So this is sort of like what we were doing in section 10.1. And I'm going to show you, a couple ways. One is it's not quite a polynomial divided by another polynomial, but if we look in the denominator, I've got n squared plus 13. So obviously n squared is the higher order term. It certainly is dominant when n goes to infinity, but it's under the radical, so the square root of n squared, right, for n greater than or equal to 0 is just equal to n. And so I'm going to basically divide numerator and denominator by n. N divided by n is 1. And then I'm going to divide this radical by n, and of course I'm going to write n in this form, because then using this property of exponents basically, or property of radicals, I can bring that under one radical and then divide both things by n squared. N squared divided by n squared is 1. And then this term 13 over n squared, as n goes to infinity, that's going to go to 0. And so our limit is 1. Generally speaking, we can just think of it like this, so a little quicker for large n. This expression, as we said, the n squared term down here will dominate the 13. It will be insignificant, so it's approximately this. So for large n, we're getting closer and closer to 1, so the limit should be 1. Okay, so that's the limit of the sequence. Now, the next question is, use this limit that we just found to determine if the series converges or diverges. Now, a little bit dangerous question, or dangerous statement here that they worded, so we've got to be real careful. First of all, let's look at this limit that we have found. That's the limit of the terms that we're adding up in the sequence. That's the a sub n's. It's not the s sub n's. It's not the sequence of partial sums. So the a sub n's, clearly limit as n goes to infinity, we just found was 1. Well, that's not equal to 0. So what does that tell us? Well, in this case, it tells us that the series diverges by the nth term test. And so the idea is, again, if this expression that we're adding up is getting closer and closer to 1, these terms rather are getting closer and closer to 1, for large value of n, it's just like adding 1 plus 1 plus 1 plus 1 plus 1 forever, and that is not going to be a convergent sum, a finite sum. This one's multiple choice, I think, can achieve. Series diverges by the nth term test, and it is because the limit is finite and non-zero is the one you want to choose. Now, got to be careful with this. It says determine if the series converges or diverges. Well, finding this limit is not going to tell us whether or not the series converges. If this limit were 0, remember, that doesn't tell us anything other than the series has a chance to converge. Okay, so it's only when this limit is not 0 can we say the series diverges by the nth term test. Okay, hope this is helpful.